Hi, my name is Shin Wachi. I'm a student of Harvard University Extension School. This is the final project for CSCIE 90 Cloud Computing on the Internet of Things, taught by Professor Zoran B. Georgievic. Um, this is the fall semester of 2016, and the title of the project is Microservice Messaging Queue on Amazon Elastic Container Service. So the problem here is short is to build a microservice message queue component and deploy the component in a cloud-based container host, such as Amazon ECS. And this microservice message queue component is composed itself is composed of three parts. One is the SIG source, which is a web service that will take requests to send a message to a Redis database queue, and the SIG sync, which is also a web service, which allows the user to retrieve various a number of messages from this Redis database queue. These are the cloud computing technology that's used. This is the Amazon ECS, or Elastic Container Service, which allows people to use Docker with the Amazon Web Service, or AWS. Microservices is just a software development method that encourages people to divide up a huge task into small manageable tasks into a separate, very maintainable applications, and then compose those applications into larger whole to do more complex tasks, as opposed to building a do-it-all monolithic application. Software containers such as Docker is a type of machine virtualization, but it's more about isolating a certain set of software rather than creating a different virtual machine for each software. It lies on the same machine. It runs on the same machine, but the software itself is in an isolated environment. Key value store, such as Redis, is a NoSQL database. It's fast and it's simple to use, and it's very popular. Flask is also very popular Python-based lightweight web framework, and this is the framework that I used to write these SIG source server and SIG sync server. So this is the code for SIG source server. As you can see, it's extremely short. Here's a preamble importing the module, creating the application instance, and it only has a single function here to handle the request to generate the message that goes into the Redis queue. And this is the routing decorator, and sometimes the user can use can have message, sometimes not. If not, then it'll have a default message, and if yes, then it'll read in the user's message value. I'll show you how that's done later. So the message gets timestamped, made into JSON, and then pushed into a message queue in Redis. The key is called message, or MSG, and the last part is a confirmation response. This is not really needed, but it'll be nice if user knows whether the message has been sent or not. And the last part is boilerplate application call. So it runs the built Flask application. SIG sync server is very similar to sync source, except in the routing, instead of message value, you get integer value that indicates the return size, meaning the number of messages that wants to be retrieved. The default return size is 5. Again, it connects to the, I forgot to mention the sync source and SIG sync. They both connect to Redis. The host name is Redis. This is indicated in the Docker compose script. This is a default port for Redis. Okay, so in SIG source, SIG sync, the difference, this is really different. This is the message retrieval mechanism. And if the here it's saying that retrieve the number of messages up to return size, and or if the message queue itself doesn't exist, then return nothing. It's an empty list. And then again, the return value is formatted into JSON and then returned as a plain text value. So I want to demonstrate running this code both locally and in the cloud. So this is the final project folder. It doesn't matter what it's named, but inside there's an app directory that contains the those two code that I mentioned, those Flask Python Flask code, as well as and in the level below there's Docker files that creates these two services, and then finally there are two Docker Compose files. Docker Compose, the first one, will actually build these Docker instance, Docker image, and here's the build instruction. The important thing to know here is the port that each of these server uses. Docker Sync uses 5050, Docker Source uses 5000, and also links to the Redis service. And Redis service is generated directly from pre-made image. I have another Docker Compose that only uses the images, so I'll try to and ask it to build it, so it'll instantly build this thing, and I can bring it up. So I run this interactively so I can debug it easily because I see the messages. And one tricky thing about running it in Mac or Windows is that you need to know the IP address of the virtual machine. So I'll do that and say curl 192.168.100, and then I'll call the SIG sync by calling port 5000 and say hello. So that creates a message hello the queue world, and that's two messages in the queue. Now I'll retrieve it using the SIG sync server, and I'll retrieve up to 5, but there's only 2 messages in there, so you'll only retrieve 2, and if I try to do it again, it's empty. So that's how these the message queue system works. So let's interrupt this. Okay, I mentioned that there's a Docker Compose file that uses only images. So I'll just call image YML. That if I try to build it, it'll say skip building because it only uses the images. So I've uploaded those custom images into Docker Hub, and now I'd like to demonstrate using this Docker Compose image YML using Docker CLI. ECS CLI. So in order to do that, I need to configure the cluster. Okay, and then now I will instantiate the cluster using this command. Okay, hopefully. Okay, now the cluster is up, and you have a EC2 instance that's running. So I will now create these Docker instances using exactly the same Docker Compose script, but instead of using Docker Compose, I use ECS CLI compose command. Now I will bring it up. So finally, I will see if these clients are running. Yes, they're running right now. These are probably from the older runs. But you will notice that if I try to access these services, you won't be able to access it because the security is not set up correctly. So I'll go back to the this cluster, and I go to ECS instances, go to EC2 instance. I will need to set up the security groups, because the inbound rule is set up to be port 80 by default, so I need to edit this, so I will have to modify it. In this case, I will say custom TCP rule. So instead of 80, I would like to have port range between 5000 and 5050, and yeah, anywhere is fine. I'll save it. Now I should be able to access the cluster. There you go. And now it's working. Great. So I'll test the SigSync, and there you have it. So that is the demonstration of the cloud service. It's available to public. Now I will tear this thing down because I don't want it to be a burden to my accounts. So now I'm stopping it. And let's check if everything is down. Yes, everything is stopped. Now I will it's very buggy. Now I will try to delete all the cloud formation stack that is hosting these services. So now that's how you eliminate the running service. So in summary, I learned that Docker allows for seamless transition from local development to cloud deployment. And I'm saying this because you can use the same Docker Compose script and the image that I used in the local development environment. No edit needed, and I was able to run it in the cloud as I've demonstrated. Now, ECS is fairly easy to use to deploy Docker system to cloud, as I just mentioned. But if you have if you don't use Amazon ecosystem, and especially if you use any other cloud services like Azure, you're not going to see any of the advantages that ECS is going to provide. So you may want to look elsewhere, but who knows if they're any better or not. And I think the development of the microservice system was easy, but that's mainly because the function of that component was very easy. I'm not sure about compositing all the, creating a lot of these small microservices and composing them. It might become pretty complex. But another thing about ECS itself, Amazon's ECS documentation is really lacking. I had to do a lot of things by trial and error, and a lot of the documentation was outdated. So you might want to, if you're a total beginner, you might want to think twice about using ECS as the first choice. Maybe there are other better supported cloud hosting, Docker hosting service out there in the cloud. So my recommendation, I'd recommend it, but only if you're already committed to using AWS ecosystem. So thank you very much for listening to this or watching this video. I hope this was useful to you, and goodbye.